Okay, so hi Miss Hedy. So today in this A Math project video, I'm going to explain to you about a question regarding the topic of trigonometric identities. So basically what I'm doing here is just proving that the left hand side will equal to the right hand side. So let's get straight to the question. So here we have tan x over 1 plus sec x plus 1 plus sec x over tan x, it equals to 2 over sin x. So here, since the variables are just tan x and 1 plus sec x, I think this will be quite easy to manipulate. So let's try. And here I'll try to make both of the denominators the same first. 1 plus sec x times tan x, 1 plus sec x times tan x. Next, this will be tan squared x, normal fractions. Okay, since 1 plus sec x is on the left, so we just need to multiply tan x by tan x. So it will be tan squared x. Same will do for the left for the next one. This will be 1 plus sec x squared. Next, we will just combine it together so it will be easier to look. 1 plus sec x times tan x. And then top one is just tan squared x plus 1 plus sec x squared. Okay, next. Since we have a quadratic equation here, we have a quadratic in bracket or in the power of 2, we just need to expand this. I think that expanding is quite easier and I think that's the right thing to do. Tan squared x plus 1 plus normal quadratic expansion. So a squared plus 2ab plus b squared. 1 plus 2 sec x plus sec squared x over the denominator 1 plus sec x times tan x. Now here, I see something different. I see that tan squared x plus 1 can be changed into sec squared x. According to the trigonometric identities, tan squared x plus 1 is equal to sec squared x. So here I can just substitute them together. Since most of my numerators majority are all in sec, I think that turning it to sec is much more easier. So sec squared x plus 2 sec x plus sec squared x over 1 plus sec x times tan x. And now we can just add this up together. 2 sec squared x plus 2 sec x over 1 plus sec x times tan x. Okay. And so next, I think that we just need to take out the 2 sec x. So it becomes sec x plus 1 over the same denominator, 1 plus sec x times tan x. Here, I think it's quite simple now. We can just cross this out. 2 sec x over tan x. Then now I'll just rewrite this become 2 sec x divided by tan x. Now here, we know that sec x is equal to 1 over cos x according to the trigonometric identities. So I'll just change it to 2 over cos x. This refers to this, okay? So I'll delete this verse. Since sec x is equal to 1 over cos x, I can just change it to 2 over cos x divided by tan x. Tan x is sin x over cos x. Then we'll just change it to multiplication. So 2 over cos x times cos x over sin x. Since it's multiplication, so just turn it upside down. Then we can cross out the cos x and we get here 2 over sin x. So there we go for the part 1 question. We can prove that tan x over 1 plus sec x plus 1 plus sec x over tan x is equal to 2 over sin x. And for the next one, hence solve the equation before here is equal to 1 plus 3 sine x. So instead of doing this, we can just rewrite this into 2 over sine x equals to 1 plus 3 sine x. Since we know that this equals to 2 over sine x. This equals to 2 over sine x. So we can just rewrite that. And here we can just do normal cross multiplication. 2 equals to 2 sine x plus 3 sine squared x. I'll just rearrange this so it will be better. 3 sine squared x plus sine x minus 2 equals to 0. And we'll just do normal factorization method. So this will give us 3 sine x 3 1 2 1. So this will be 3, this will be 2, and negative 2 here. 3 sine x minus 2 times sine x plus 1 equals to 0. I'm just doing this. Now, then here we can just rewrite sine x as equals to 2 over 3. And then this one, sine x is equal to negative 1. Since the range is here, I think that this will not be possible. So let's just take this, okay? Take this. The range is 0 to 180. Sine x inverse 2 over 3. This will give us two answers. Since this is sine, according to ASTC, sine is on the second quadrant and on the first quadrant. So this will be on quadrant 1 and quadrant 2. Let's use our calculator. Sine x 2 over 3 and degree. This will give us 41.8 degree, and since this is on quadrant 2, so just 180 degree minus 41.8 degree equals to 138.2 degree. 138.2 degree. There you go. So this will give us, so this equation was solved, and this will give us 31.8 degrees and 138.2 degrees. So that's all. We have 9 points in total for this question, and I think it meets up the requirements already. So thank you, Ms. Hedy, for watching my video. Hope you understand it and hope my explanation is clear enough. Thank you for listening, and goodbye.